Hello, everyone. Thank you for joining us for our very first official Infura Developer Community Meetup. This will be a monthly call. We hope to continue. So thank you so much for joining. I'm Shay, and I'll be your MC today. A little quick housekeeping around Crowdcast, which is what we're using. On the right-hand side, as you know already, there's a chat that is ongoing, so you can feel free to have conversations there. If you do have a question that you'd like one of the speakers or one of the team to answer, please add that to the Ask a Question queue that's at the bottom there. Already there's one question, so you should see a little kind of bubble. If there are questions in there that you also is something you want answered, you can upvote them so that they get to stay at the top of our radar. You do have the option to come on stage and ask the question yourself if you'd like. So when we do have a question, I'll ask if you'd like to do that. You can simply tell me in the chat yes or no. If you don't want to come on stage, then I'll go ahead and ask it on your behalf. We'll leave some time at the end also to have Q&A, but we'll try and answer questions as they come up so that we can kind of keep them relevant to the context of the content we're talking about. And then there's a poll that we have. We would love for you to answer that so that you can give us a sense of where you guys are, your experience level around Infura, so that we can kind of focus the content to your needs as well. Without further ado, I'll hand the microphone to Sarah.
Thanks, Shay. Hello, everyone. Really happy to be here for our first Dev monthly comms call. And so good to see so many of you from around the world as well. So for those of you who don't know Infura, we are a Web3 infrastructure company. So we provide access via APIs to Ethereum nodes, the IPFS networks, and some of the layer 2 nodes as well as building out cool features and products and really helping that developer experience move forward with Web3. So my name's Sarah Feenan. I'm a product owner here at Infura. I've been here 6 months and spent around 5 years nearly, scarily, in the Ethereum ecosystem. So I'm just here to do an introduction. As you can see on the screen there, there's an agenda. So coming up after me will be Paddy McCorry, our lead engineer. He'll talk you through ITX, which is a special sort of transaction optimization feature that we have on the Ethereum network, which I'm sure is an issue close to all of our hearts. And then coming up after that, we're going to speak about IPFS, which is the Interplanetary file system, which is a Web3 version of, say, AWS. It's all about decentralized storage. So the team here have been working really hard over the past few months to really improve and make more robust our infrastructure. So we're really excited to be in such a good sort of base level there. And you'll hear more about the additional features around IPFS and where you're going to go. So you can hit me up on Twitter. I'm Seronimo. I'll also be lurking around in the community forums quite a lot. So I'd love to speak to all of you about what you're working on and what you're building, especially in particular on IPFS. It's such a new space. So that's enough from me. I will now hand over to Patrick McCorry.
Awesome. Thanks for that, Sarah. I guess you're in control of the slide, so I'll let you jump to the next slide. Also, good morning, everyone. If you want to drop a GM in the chat, you know, it's a very nice crypto meme. So GM, everyone. So what I want to talk about today, I guess I'm supposed to introduce myself. So my name's Patrick McCorry, and I was told to say one fact about myself. I guess I've been doing this since 2013. I did my PhD in Bitcoin and Ethereum, sort of before Ethereum even existed. And now I'm sort of like an Ethereum maxi. So I hope you all enjoy this wonderful talk. Look at all the GMs come in. That's wonderful. So what I'm going to talk about today is basically the Infura Transactions service. So one question is, and I'm sure everyone's had this issue, you know, when was the last time you had a stuck transaction and how did you deal with it? You know, no one really likes stuck transactions. It's something that we need to solve. So let's jump to the next slide. So why do we get stuck transactions? So what I would normally say is we would get stuck transactions because of the fee market. You know, you submit a low fee, you send it, you know, miners don't like low fees and they don't include your transaction. But it's different now. This has changed since EIP 1559. So if you just jump to the next slide. thanks to EIP 1559. Oh, one slide back. Oh, okay. I can just continue. Oh, yeah, that's perfect. Awesome. So the issue is, or I guess the benefit is, thanks to EIP 1559, we don't have to worry about the fee market anymore for stuck transactions in 99% of the cases. And that's because there's a single bidding strategy on the network. You set your base fee, you set the maximum fee. If the fees start going up, your fee will also go up with the network. So we don't have to worry about network fee anymore for stuck transactions because, for the most part, for 99% of the time, EIP 1559 does help with that, which is awesome. So let's jump to the next slide. And then why do we end up with stuck transactions anyway? Because stuck transactions haven't gone away. So the Ethereum network basically has this network policy rule where if you send 16 transactions in a row, or more than 16 transactions in a row, there's a good chance that the Go Ethereum or nodes in the network may drop your transaction during congestion. And if you jump to the next slide, so I'm going to do this every time. Awesome. So there's this special network rule on Ethereum that makes it sort of awkward. So every time you send a transaction, every transaction has a nonce, 1, 2, 3, 4, 5. If transaction 3 gets dropped, but 1, 2, 4, 5, 6 is still on the network, then you're going to have a list of stuck transactions. Number 1 will get mined, 2 will get mined, 3 is missing, and so 4, 5, 6 gets stuck. And that's typically what happens, when we get complaints at Infura about stuck transactions. A lot of the time, there's a nonce gap. And now this isn't really a make-believe problem. The classic example was Black Thursday back in March 2020. I don't know if you guys remember this. The price crashed to like $100. Everything was on fire. MakerDAO was sort of suffering. They later on, subsidized it with their token sale. But basically, the mempool on Ethereum, the list of pending transactions were so full that there were a lot of dropped transactions. You can see here in the graph. Look how many. That's like 50,000 transactions being dropped. So if you jump to the next slide, one good example was the MakerDAO example. So basically, as some people here might be aware, MakerDAO has these liquidation auctions. I don't really need to explain how the liquidation works, but the idea is that there's an auction triggered. Everyone submits their bid. Whoever submits the highest bid will win the auction. The problem back then was that these, I think they're called liquidator bots or keeper bots. Because there were so many auctions, they were just flinging out lots of bids to lots of auctions. But because transactions were getting dropped, none of their bids for the auctions were being processed by the network. Now, there were good examples of them setting 4,500 as a fee, and that still wasn't good enough. They unstick the transactions because of the nonce gap issue that I mentioned before. So even if you set a mega fee, if you're missing an intermediary transaction and an intermediary nonce, your transaction will always get stuck. And that is like the worst thing ever. No one wants that. So we jump to the next slides. Solving these problems is not really trivial. I guess normally when you think of a relayer, you think, oh, relayer is going to be really easy. I'm going to write a little script. It's going to manage the nonces. It's going to send these transactions out. And so it looks like a trivial problem, but when you start writing it, it's tedious, it's fiddly, it's boring, and needs dedicated infrastructure. No one really wants to write any of that. It's really boring. You get all these unsatisfactory guarantees. And the problem is solve it. You still haven't solved it, but now you've spent 3 weeks on it. So you just want to keep working on it until you solve it. And so we built ITX, so you don't have to do that at all. You shouldn't really be having to write your own relayer to interact with Ethereum. So we jump to the next slides. Sorry, I'm just doing my little dance until the slide moves. But I guess I don't really need. Oh, there you go. So we basically built the Infura Transactions service. The idea we provide data. You don't have to deal with nonces. You don't have to set the gas price. we take your transaction, we stick it in an Ethereum transaction, we send it to the network, gradually bump the fee until it gets mined and confirmed. If you send us 100 transactions, we're going to process transactions in order and make sure you never do a stuck transaction. And so, as you know, as an API, a relayer as an API, so it's fairly straightforward. And I think that could be my last slide. I'm not sure. But if you have any questions, by the way, drop it in the chat, do it in the ask question box. I'm happy to answer questions over the next hour while we're all here. Cool. I think that's it, isn't it? I don't actually see any slides now myself.
All right. Yes. Thank you, Patrick. Sorry, I'm trying to toggle the mutes and all. I just realized we had a speaker on that was echoing. Sorry about that. All right. So, yes. Before you go, Patrick, I don't know if we had any questions that we can answer while you're here. We do have someone, let's see if, I don't know if I'm pronouncing it right, Furcho, saying, how does it work? I hope that applies. And another one's saying, doesn't that giving a tip one in the same situation, or doesn't not giving a tip leave one in the same situation? So I don't know which one you want to speak to.
I can do both. So if you set a tip in your transaction, there's a minimum tip that you have to set. I think it's like 1 GUI or less than 1 GUI. And if you don't set a tip, then your transaction just won't get relayed to the network. So yeah, you'll end up with a stuck transaction, although ideally your wallet provider should reject that and not let you do it.
And Sarah, can you, sorry, there you go. You're back. All right, great.
I just do a coding example. So if I flick over here, I've got a little coding example. I just tested it before to make sure that it works. So we just jump in here quickly. I zoom in. It's pretty straightforward. This is Ether.js. You get your Infura provider, your signing key. You get the transaction that you want to send. So we have a demo contract that does echo, hello world. You sign it, and then you send it to us, ITX.send relay send transaction is a new JSON RPC. It'll return back a relay transaction hash. And then you can ping our status API to check that it gets mined. And so if I just run this, I'll do the script, and it'll give me the hash, and now we're just waiting for it to be mined. And we're doing this on Rinkeby, so typically gets mined within 1 block. Well, that's the basic idea. It's fairly straightforward. You're just using your Infura provider on Ether.js. You're using a new, 2 new JSON RPCs, and it's fairly straightforward. The only thing that you have to worry about is, in order for us to send a transaction for you, there you go, it's been mined 1 block. Awesome. But in order for us to send a transaction for you, you need to top up a gas tank in advance. And so that just covers the cost for sending your transaction. But that's it. And then you top up your gas tank, and then you can start sending transactions. So I guess that's I think that's the only question, isn't there?
Yeah, and the other one was, how does it work? But I think you answered that in that question. And on the chat, as you can see, Trish is leaving some good links to find out more about Infura Transactions, which is ITX. Another question from Lorenzo: how do you prevent the high gas spending for each consumer?
Historically, oh, whoops, I'm muted.
You're muted again. Whoops.
Okay, awesome. I'm back now. So historically speaking, before EIP 1559, we would take an estimate of the current gas price and send the transaction in at a 30% discount, and then we'd rapidly bump the fee until it gets in. And we were basically saving around 30 to 20% compared to the fast rate on gas now or ETH gas station. So we were actually saving people money. And then with EIP 1559, everyone is performing the same bidding strategy. As long as you pay the base fee plus a tip, it gets in. So what we do is we gradually bump the tip. And that allows us to, by bumping the tip, we can front run people during congestion and make sure your transaction gets mined first. And there's reasons why you'd want to do that to save money.
Great. Thank you, Patrick. I think we're going to move on to, and now if there's any questions we miss, again, there's going to be time at the end for Q&A. And just a reminder, I forgot to mention, at the bottom, there's a green shiny button that says join us on ConsenSys Discord. If you aren't already in our community, please join us there. You can continue the conversations we have today with the team in that Discord community. All right, so let's hand the microphone to Tay. And any tidbit you'd like to leave about you, Patty, about any kind of fun fact before we go and hand the mic?
Oh, me? A fun fact?
Yeah.
I mean, I think my fun fact is, I've been doing this like crypto for 7-8 years, and it's probably the most fun I've ever had in my life. So just find some job or project or work that you actually enjoy doing. There's so much work. I mean, there's so much need for recruitment out there that every project's basically hiring. So just go find something and have fun. That's it. GG.
All right. Sounds good. All right. With that, I'll hand the mic to Tay. Thank you, Patrick. All right, you're on.
All right. Can we get to my first slide, please?
Thank you, Sarah.
Thank you. Hi, I'm Tay, CEO of Gluwa. I'm happy to be here for Infura's Developer Community Meetup. Fun fact about myself is I'm an art collector, but didn't get to buy an NFT yet. I'm still contemplating the idea. So today I'll cover why Gluwa has chosen ITX over building its own relayer service. Our business has started to grow in recent years and serving over, next slide, please. Oh, yeah, this slide. There's a lag between my screen and that, Sarah probably. All right. So our business has started to grow in recent years, serving over 2 million users and have facilitated over 1.2 million transactions. And we love our users and growth, but more transactions mean more of them getting stuck. Also, if you get large enough, the gas fee optimization problem can make or break your business. So we have adopted ITX, solve these problems, and focus on our core business. Next slide, please. Gluwa is a borderless financial platform that connects the ideal capital of the developed market to the high growth of the emerging market. Typically, in the developed market, average users get a worse interest rate than the inflation rate. On the other hand, in many parts of the world, people are unable to get a line of credit, even if you're willing to pay double digits APY, unbanked or underbanked by traditional financial institutions. By bringing the best of both worlds together, providing competitive interest rates to investors and affordable loans to borrowers. We do this by first building a verifiable credit history on a public blockchain and running a borderless investment fund on Ethereum. Powered by public blockchains, we have opened up a decentralized credit bureau and credit investment market accessible to anyone on the internet. Investees of our ecosystem accumulate their credit history on top of a public blockchain credit coin, building their credit profile for the future. Better the record, they can expect lower interest rates and more extensive credit line. On the other hand, investors can invest in the emerging market through a smart contract-based investment fund. They can see their committed fund getting invested and follow its activities on blockchains. Under the hood, Gluwa is an interpolable blockchain system built on top of Ethereum, Bitcoin, Creditcoin, and more. Each blockchain serves a specific purpose in this system. We use Ethereum as the base layer blockchain where the payment finality is confirmed. Thus, we have been using Infura for years. In an ideal world, we want our transactions to get submitted in a row without skipping any in between. But as you know, each Ethereum account must associate a nonce with its transaction. The nonce must strictly increment by 1 for every new mined transactions. And in reality, Ethereum transactions often get dropped by the network or get stuck due to insufficient fees, blocking anything that comes after it. Transactions get stuck more often when the fee market is volatile and the network is congested. Unfortunately, that's when the problem gets most critical. You can solve this problem by building a transaction relayer. A relayer needs 3 core components: monitor, republisher, and fee estimator. You need to monitor across the network to quickly find out if your transaction is successful or not. The longer it takes, the more backlog transactions you get. When you find out your transaction is dropped, you need to regularly republish the transaction back to the network. You will need to manage a pool of addresses to avoid your earlier stuck transaction from blocking the new one. The fee estimator needs to calculate an exact fee for your target delivery time. Also, it has to quickly adjust itself based on the market change. However, building all these components in-house is not straightforward. After building and using a primitive relayer service in-house, we have concluded that building a satisfying in-house relayer will take some effort. As we run into new challenges, we have to enhance our architecture and implementation. Soon after a few cycles of planning, it has grown into a project of its own. For business, it made sense to us to adopt ITX over building and maintaining an in-house relayer. We wanted to focus on our core business model instead. Currently, ITX provides Gluwa a ready-to-use relayer service with minimized integration effort. Using ITX, Gluwa can scale up transaction per second and prevent transaction congestion. ITX has a sender pool to help us submit transactions so that when a transaction is pending, it won't affect the other. By doing that, allows us to submit multiple transactions without waiting for the earlier ones. We can also improve transaction finality. ITX offers two schedules, fast and slow, which are used by ITX's built-in retry service to replace pending transactions to ensure they are completed within the target time for each schedule. Fast takes 1.5 minutes and slow takes an hour. Lastly, ITX can potentially save us gas by its relayer service. We'll try the lowest gas fee and increment it over time during the targeted schedule. In the long-term vision, Gluwa expects the next generation of relayer services should be able to do the following, to provide following services. First, advanced gas optimization. There are a couple more tricks we can use to save gas fees. For example, batching multiple transactions together to save gas fee even further. Second, smart gas prediction. A relayer service should be able to predict what is the optimal gas price within a period. Increasing gas prices over time may not work when gas prices fluctuate faster than the target time. Third, to allow submitting tips to miners so that transactions can get prioritized when it's necessary. Fourth, transaction timing optimization. By not only adjusting the fee, but also timing of the publication to when the network congestions get slower, we may save the gas fee even further. Lastly, support gas token minting to get gas tokens when gas prices are low and then redeem them when they are high. Note that some of these suggestions may already have been implemented under the hood, as ITX allow us to worry less about the transaction publication. We don't have to know everything anymore, which is nice. Next slide, please. All right, thank you. If you're building on Ethereum and want to serve millions of people, relayers is a must, but not simple. And try ITX, it works, saves time, and focus on your core business model. We hope to see ITX get advanced even further. More people using it would help. Lastly, Gluwa is hiring, so we are hiring for various positions. If you're interested in building an inclusive financial services for millions of users, visit our website, gluwa.com. Thank you for listening, and I guess I will now toss the mic to the next speaker, Discordian from Protocol Labs.
Thank you, Tay. Before we hand the mic over to Ryan, are there any questions for Tay? I know we have some in the queue, but relevant to what he was going over. Again, we'll bring everybody back up for final questions at the end. If not, thank you so much. We really appreciate that. And we are going to bring on, let's unmute, and there's a video. Oops, yep. There you go. All right, thank you, Tay. And now we'll hand the mic to Ryan.
Alrighty. Hello, everyone. I'm Discordian, aka Ryan from Protocol Labs. Excited to be here for Infura's Developer Community Meetup. I'm going to be giving a brief, under 10 minutes introduction to IPFS. So, what exactly is IPFS? IPFS, aka the Interplanetary File System, is a peer-to-peer data storage protocol. It's typically used over the wider public network, but will work fine within a LAN, and can even be used in a private network over the internet, encrypted using shared keys. IPFS addresses contents using CIDs, and data is shared peer-to-peer between people using IPFS. A CID is a unique identifier that helps with data discovery and deduplication. CIDs are generated by the contents of the data, be it a file or even a directory, ensuring that each CID is unique to the data it represents, and is immutable. If two users create a CID off the same data in the same way, they'll end up with the same CID. This is how IPFS achieves deduplication and immutability. IPFS can also utilize IPNS, aka the Interplanetary Name System, to have one CID that can be updated to point to a new CID. This works by the publishing node generating a key pair, and then that node can publish CIDs to that associated public key. If this key or IPNS address is shared, then a receiving node can access the latest version of content using that IPNS address as the publishing node publishes changes periodically. IPFS is built upon libp2p. This is used as the backbone of IPFS for peer-to-peer communications. For practical application uses, this gives us access to an easy-to-use publish-subscribe system, aka PubSub. We can simply subscribe to a topic we're interested in, as well as publish to it. All subscribed peers will see the published message, even if they are not directly connected to the publishing peer, as other connected peers can assist in passing the message around to interested peers. IPFS is also accessible over HTTP via public gateways such as IPFS.io and Infura. This gives non-IPFS users a sort of portal into IPFS without all the features of running their own node. It also allows you to share data you have on IPFS through an HTTP gateway, which is useful when also publishing to non-IPFS users. And thank you. So now you know what IPFS is, but not necessarily why it's useful. IPFS is useful because it allows us to have decentralized distributed data storage. No longer do you have to worry about an AWS or Fastly outage, as your data can be spread among many nodes across the world as users access your data and automatically reserve that data from their nodes as they do. With Filecoin, you can make storage deals to have storage providers ensure your data is available for a term at a fraction of the cost that the big centralized servers charge today. With IPFS, there are no central intermediaries required. So, when you're looking for a specific picture, for example, you don't need a specific server to give you that data. Instead, you are looking for the data itself by an immutable CID, so any peer can provide that data. Additionally, if two peers were communicating, like with a chat application or social media, the data can transition directly between those two peers without the need of a third-party intermediary. You don't have to rely on you don't have to rely on being able to trust a third party or abiding by their terms of service. This also has the added benefit of there's no server that can go down and cause an outage. The peers just need to be able to find each other. IPFS actually has a negative bandwidth scaling cost. I touched on the fact that users will automatically reserve your data as they access it. Think of the following situation. You set up a website, perhaps you get tens of users per day. Not too difficult to handle. However, what if you happen to create something that explodes in popularity, goes viral, with potentially thousands or millions of users? Well, in a typical HTTP scenario, you'd have a big scaling dilemma to deal with, complete with high server and bandwidth costs. With IPFS, users are looking for your data by its content ID, the data itself, rather than where it's located. As users access your website, they retain a copy. In the scenario where you now have potentially millions of new users, those users will be reserving the data to nearby users looking for your data, spreading the loadout across those millions of users. So effectively, as you get more users, your bandwidth costs can actually go down because your data is more readily reserved by the users themselves. It's easy to get started with IPFS. We have many learning resources available, be it workshops, proto.school, the IPFS docs themselves, and our wonderful community. Tools like Infura give you access to an IPFS node that's hosted on their end, enabling you to be able to quickly get started and try IPFS out. Services like Web3.storage, NFT.storage, and Fleek allow you to store data on Filecoin for free and access it over IPFS. This makes it very easy to have your data available long-term through the use of simple APIs. At this point, you might be wondering, how can I get started? Well, it's quite easy. We have a variety of documentation to help you out. IPFS Desktop and IPFS Companion are great starts. IPFS Desktop will set you up with your own local node and let you experience IPFS firsthand. IPFS Companion is a browser extension which can interface with your local node, loading web pages which support IPFS through your IPFS node. With these tools together, you can comfortably use IPFS through your web browser without having to do too much configuration. If you're a developer or even a power user, you might be interested in our how-to guides. We have a lot of them in our docs, and they should be very helpful, be it learning how to use the command line tool or developing your first fully peer-to-peer in-browser chat application. There's a wealth of information contained in there. Going even further, we have a brand new Getting Started page we've created. It has all sorts of helpful links, tutorials, workshops, tools, you name it. I highly recommend checking it out. I'm sure you'll find something helpful in there. So if you want to learn even more about IPFS, then the best way is to join our community and engage. We have learning resources available, of course, like our docs and proto.school. However, I also encourage you to join our chat and forums too. We have a large, very friendly community. Maybe you'll find your next partner for your next project, or just some people to hang out with and talk about the future of the web. Either way, we'd love to have you. Once again, I'm Discording from Protocol Labs, happy to be here for Infura's Developer Community Meetup, and I hope you are too. I'll now hand it off to the next speaker, and that's that.
All right, great. Thanks, Ryan. Great radio voice. So yes, with that said, we are going to move over to Lucas. But before we do that, let's see here. I'm going to do a quick, you have a couple questions, or actually at least one question, Ryan, coming in from, this is more of a, how should I phrase this? What's the coolest use case for IPFS? What do you think it'd be,
well, it's hard to put it's hard to put my finger on just one, really, because like I think it opens the doors to like all sorts of like really cool use cases. I'd say the most recent thing that I was thinking about that I think is really cool is I touched on it, is the concept of like having social media no longer require a single central source of truth. The fact that using these kind of decentralized technologies, we can now set it up so social media now becomes as organic as real life conversations. Like when you meet somebody, the data can go directly from peer to peer. And that way people are actually organically engaging with each other, and you no longer have an artificial algorithm deciding what you see or who you interact with. It's now just as organic as it'd be in real life. So that's right now the coolest thing that's been on my mind about things that could possibly be built with like IPFS and decentralized technologies like that.
Nice. That's great. All right. So with that said, thank you, Ryan. I'm going to bring Lucas up. And one thing before we go to the next speaker is, let's bring Ryan, Lucas, thank you. Polls, quick poll check here. If you guys have had a chance to just fill that in, you can still do that now if you'd like. We just want to get a sense of what everybody is currently building on with Infura. So it looks like mostly, as expected, Ethereum mainnet. We do have some Polygon, Solana, BSC, and Avalanche. Okay, so that's good to know. So this helps our product team understand where you guys are at. And again, please join us on Discord to let us know if there's any areas where you'd love, any questions you have around that, building on those different chains. Also, like if you have any kind of suggestions or like features or things, this helps us really understand some good feedback of how to enhance and provide the best tools for you guys. All right, without let me hand the microphone over and go ahead and share your screen there, Lucas. You're going to now drive the slides. Let's make sure we get those. And then once you have the slide up, go ahead and introduce yourself, tell everybody what you do, and maybe a little fun fact about yourself.
Okay. Can you see the slides, right?
Yes, yes.
Okay, perfect. So, hi everyone. My name is Lucas. Next week, it's going to be exactly 1 year since I joined Infura to work on the IPFS project. Ryan's headphone game is, by the way, on a very high level, so I'm jealous of that. And in this presentation, I want to present you the IPFS from the Infura perspective and how it can help you. So what I'm going to mainly focus on is the best parts about hosting IPFS content. I will talk about our API features and how you can get started in the most easy, feasible way possible. So why you should connect your Web3 application to Infura? I think the number one reason is that our API is fully compatible. So whenever you want to add a file or pin it, read it, whatever you wish, you don't have to do any changes to your current setup, to your current business logic or application. You only have to swap the endpoints and point to Infura. We are also running the latest Go IPFS code. So we are currently 0.9.1. So we are trying to stay up to date with Protocol Labs and the entire community. What we want to mainly achieve as Infura is help you scale and navigate the crazy spikes in the crypto sphere. So whenever you are launching an NFT project or you are promoting your website currently, and let's say the website is loading a lot of content from IPFS, this is our goal. We want to make sure that all the content is servable without any extra latency, and that we can help you scale to whatever level you need internally without any changes necessary from your side. The easiest way to get started is creating your own project. So to put an example, this is how the project dashboard looks like from a registered user perspective. You can create a new project, you can have multiple projects, and this is very useful. So for example, over here, we are looking at 4 projects. This helps with different things. So for example, the credential segregation, as we will see in the next slide. It helps with content organization. We will get to the dashboard explorer as well. And it especially helps with kind of experiments. So if you have one project for your application, and then you want to run an experiment and try to maybe test your script that would add or pin a lot of content, and you don't really want to mess up with statistics with other projects, you could just create a new project for this specific use case and keep everything clean, and then just delete it or create a new one as you need. So we want to focus on a good UI for you, so everything is like clean and organized. The one extra layer that Infura adds to the standard IPFS is the basic access authentication. So the moment you create your project and you give it a name, for example, community called demo, you are going to get assigned credentials. Sorry, project ID and project secret. These two are very important, and the way they work is that with every API call request that you make to Infura IPFS, you will add an additional authentication header. So we are using a combination of concatenating the project ID and project secret, encoding it in base 64. You ship that header with every request, and thanks to that, your content is going to be assigned to the correct project ID. If you have never done authentication for your application, no worries. We have a specific section on our documentation page in the section of authentication, and we created full snippets, complete snippets that you can use in with 6 different examples. So whenever you want to just test something with curl, or you want to run JavaScript or Node.js, or maybe any of the official Go IPFS libraries, either in JavaScript or in Go, you can just go to the page, to the documentation page, copy the snippet, change the project ID and project secret, and you are set up. Nothing else is needed. So we want to make it very pain-free for you to get started. The moment you create the project and use this authentication header for your API request, what's going to happen is that in the Project Explorer, you will see all the content that you are working with. So this is super useful for ordering or organizing your content and ordering it, for example, by the data size. So you see, okay, what is the biggest file or biggest content piece of data, because IPFS supports all kind of data that you are hosting. Okay, this is 3.6 gigabyte. It was pinned at this and this date. And thanks to this dashboard, you can control the space you have in your project. So at any time, if you pin something that you don't want to host anymore on the peer-to-peer network, you can just unpin it. And that's the point of the dashboard. Another cool thing, which is quotas setting. This will enable you to control your expenses. So let's say you are launching an NFT collection and you are expecting a lot of traffic. You want to, maybe you have a script that you want to add a lot of content, like you want to store a Wikipedia on Infura for whatever reason to help share the knowledge in a decentralized way, but you are not sure what's going to be the final size of this content, of this list, of this tree. Then you can control these settings through these storage quotas. And if you exceed that, then you are going to just get an error, but you won't overpay anything. And from the security perspective, when you go to your settings security tab, again from the Infura website, what you will be able to do is control the source of the traffic. So let's say you are running a script on some server and you know that, okay, you want to only accept traffic from this server. You can go to this page and configure how you want to limit your requests. And the same thing you can do with the HTTP user agents or the origins if you are running a website and you want to make sure that the content is coming only from your website and no one is hijacking you. So all this sounds cool. How can you get started, right? Infura offers a starting pack, which is pretty large for an application. You will get 5 gigabytes of free storage and monthly transfers. And if your application gets more popular and you are going to need more storage, more transfer, you can just upgrade to Plus. Again, no other changes necessary, and you will unlock all the benefits of using Infura as an IPFS provider by having that unlimited storage, unlimited transfer, and performance that you need. To get started, I think it was 2 months ago, we created IPFS Copy tool. It is open source, super simple tool. You can check it out, make sure it's not malicious or anything, and you can either compile the binary from source yourself, or you can download the pre-built binary. And the useful part about IPFS Copy is that it will allow you to migrate to Infura without much of a overhead or troubles, without writing a lot of custom scripts on your side. So if you are already an existing customer, and you were using Infura for the last months, maybe last year, and you have a lot of free content that you know all the CIDs about, what you can do is use the IPFS copy command, and you can define the CIDs flag. And then your credentials, of course. And the CIDs file is going to be a file where every line is separated by a line break character with a CID in there. And what's going to happen is that the IPFS copy command is going to take all those CIDs and pin them to your project. Right afterwards, they are going to be available in your dashboard. They are going to be republished to the peer-to-peer network, so other providers or other nodes on the IPFS network can access them, and so on. On the other hand, if you are a new customer, and let's say you are hosting currently all your content on your local machine, or you have a dedicated instance, and you want to make a copy of this content or make sure it's available from different nodes, to build a bit of a resiliency for your application, then what you can do is, again, use the IPFS copy command, define the source API URL and your credentials. And as the URL, you just have to specify the source IPFS node where the content is going to be migrated from. So what's going to happen behind the scenes is that the IPFS copy command is going to look at all the blocks that you have pinned at your source machine. It's going to iterate over them in multiple workers or Go routine threads. And for optimal performance, you can also control that, depending how much content you really want to migrate. And it's going to copy them to Infura, pin all of them, again, display them in the dashboard. And once it finishes, it's quite fast. Then your entire migration is done. Basically, with one command, you can switch to us. So that's about it. Thank you for your attention. And now we can move to the Q&A section.
Yes, thank you, Lucas. Okay, before you go, we do have a couple questions. One is, how does Infura take a decentralized approach?
Sure. So the thing about IPFS or having another, let me close this. Okay, now. So how do we take the decentralized approach? So because Infura is 100% compatible, because our IPFS API is 100% compatible with the official IPFS API, just because you host our content with us, it doesn't mean this content is centralized with us. If anything, you are basically more decentralized because now you have your content on your node, which if it catches fire, is also on our node. And because we are constantly republishing it to the peer-to-peer network, is also on the other nodes that decide to pin this content. So it's not, the trick with IPFS is that it's not like a magical black box where you just upload your content and it's like done. It's on the internet forever. Like, no, it is only there or until then, until there is a node pinning this content. So by going with Infura as your IPFS provider, you ensure that this content is pinned and available on the IPFS network constantly. Make sense?
Great, thank you. Yes, and then we have another one. What is the most interesting use case of IPFS you've seen so far? Similar question.
I have one in my mind that I always say when someone asks me this question. I would really like to see a decentralized version of Instagram built on IPFS. The reason for this is simple. I don't like when one platform is controlling all the content, because then the users are kind of kept hostages. They cannot just migrate to another platform. So the good thing about if you would build a decentralized Instagram on IPFS, what you can do is that as you are hosting all your content, the application is basically acting just as the UI. The content is loaded from your node. And if you like if another application comes up, like Instagram 2.0, rebranded, a different company is competing with it, and they build a better UI with better features, then you can just switch to it. But you don't lose all your content, all your hard work that you put into the platform over the years.
Great. And Lucas, do you mind resharing your screen again and putting it on the last slide? We have one more question for you while you do that. It's coming in from Peter. How are you different than Bison Trails? He wants to know.
It's Bison Trails. I'm not familiar with Bison Trails, honestly.
Okay.
I can answer that if you want. I'm
Awesome.
familiar with them. Basically, Bison Trails they were acquired by Coinbase recently. And the idea is that they run nodes in your behalf. So if you want someone to run Go Ethereum for you, or a Dime node, or a, I don't know, Cosmos node, you basically sign up to their servers and they'll run a node in your behalf. Where Infura is not really doing that. Infura is an API that provides data for you about the blockchain. So you don't have to run any node. Just connect to the API, you make a request, and you get the data. So you're using Infura nodes. So that's basically the difference there.
Thank you, Patrick. Yeah. Oops, we lost your screen share there, Lucas.
Yeah,
Oh, no, we got it back.
Hear me, like,
Great. Okay,
yeah.
this is the last step, last slide. Perfect. Let me see here if we have any more last questions for you. And I thank you, Patrick, for jumping in there. I think what we'll do is we'll move on to, we have a bunch of questions in the queue, so this is great. And we'll bring Trish on stage to be able to field those for you guys. Let's see here. Okay, Trish, I'll hand you the microphone. And you have this, you can see the slides, everybody. I'm hoping, yes. Okay, thank you again, Lucas. And we'll bring on anybody who needs to answer questions. All yours.
Hi, everyone. I'm May or Trish. I'm the product marketing lead for all developer tools. I joined Infura about 2 months ago, and it's been just a fun ride. Very excited for the community call today. Everything was really great. So I'm going to move on to some questions for the group. And first off, I'm going to bring up Patty. Patty, you said that if we send a series of transactions, say 10, you will process them one after the other. If I understand, you wait for the validation before sending the next transaction, which in turn makes the processing time longer. Does it imply that ITX is particularly indicated for big batches of transactions, where the order is critical, or where we cannot afford to see our transaction not being executed? This is from Hadi Sakali. Thank you for the question, Hadi.
Awesome, thank you, Hadi. So basically, when you send us a transaction, we just do some basic sanity checks. We internally we check, okay, does this user have a balance in their gas tank to cover this cost? If you do, we just append it to our transaction queue, and we'll hopefully broadcast it to the network immediately. So there shouldn't really be a hold up if you're sending us 10 transactions in a row. They should all hit the network immediately, and the only hold up will be whether an Ethereum miner picks it up or not. So there shouldn't be any delay in that regard. If you're sending those like 30 or 40 transactions, there may be a slight delay, and that's just because we want to guarantee they all get, they don't get dropped from the network. What was the second part? I think I answered it, didn't I? Was there any other part of that question?
Does it imply that ITX is particularly indicated for big batches of transactions?
Oh, yeah, yeah. So, I mean, there's two cases. If you're sending a big batch of transactions, then ITX is also really useful for that. We've been doing some experiments on Polygon, and so networks with high congestion and throughput, they tend to have more unreliable transaction delivery. So if you just want to guarantee a few transactions get delivered on Polygon, actually ITX is really useful for that. It does appear that a lot of transactions get dropped, even if you send like 2 or 3, just because the network's so heavily congested. So it's really useful if you're building a server-side application, and you're in charge of sending your users transactions, then it's a really useful service. So your users don't have to deal with stuck transactions anymore.
Oh, and another question for you, Patty. A lot of people are interested in ITX, obviously. How much gas fees do we need to send so that ITX can make sure our transactions can be mined? Thank you, Purnima, for your question.
Basically, you just need to have a gas tank. So what I'd recommend is, if you wanted to test it on Polygon, I'd top it up with like $5 and then try it there. If you want to try it, although I guess it's not officially released yet, but we do have a running instance. If you want to do Ethereum, I'd probably top it up by like $50 or $100 and just send a few transactions that way, because Ethereum transactions are quite expensive anyway. So I would just do a few transfers and just see for yourself how well it works. But generally speaking, it's a prepaid service. So if you want to send a transaction, there should be some funds there that will cover that cost.
Awesome. Thank you, Patty. This question is for you, Tay. How has ITX helped you become more efficient as you focus on your go-to-market? I think you're muted, Tay.
Yep. To build an equivalent, you would need to allocate architect, backend engineers, smart contract engineers, QA, DevOps. We probably won't need to work on it, to work on the project full time, but it adds up. And to work on one more project is really taxing to the team. So roughly estimated, we calculate that it saved us to adopt ITX saved us about 3 to 6 months of our time.
So ITX saves the day.
Yeah.
Awesome. So this question is for Discordian. I'm not sure if he's still on this session. I think he's asking, how is IPFS for free? How does it work? Don't you need Filecoin for storing your data? Discordian, is Discordian still? Oh, hey Discordian, can we have Discordian back on stage?
Yeah, bringing them on right now. I'm gonna drop your screen share, Lucas, just for a second, so we can invite Ryan back on, aka Discordian. Here he comes.
And thank you, Furcho, for the question.
Let's see here. I guess, yeah, he's joining now. And let's see. And we do have a few minutes, so maybe Trish, as he's coming back on, pick one more good question. And just so you know that all these questions, if we don't get to them today, we can pick up this conversation and help answer some of these questions on the Discord Infura channels. So please join us there. Everybody who is on the call today, you can chat directly with them, which is great. Let's see. Let's get Ryan up here. He's joining. It looks like he's trying. Go ahead and share your screen again, Lucas. Sorry, I think 1, 2, 3, 4, 5, 6. He should be able to join. Okay.
So while Discordian is maybe joining on the stage,
Another question.
Why don't we have Lucas answer this? How can one leverage IPFS so that front end is immutable? This is from Peter. Great question.
I can answer also the previous question if needed. The thing with IPFS is that if you create a website UI and you add it to IPFS, then you can always reference that particular stage or the particular commit of the website in an immutable manner. So if that website changes, obviously you will have different content, different JavaScript, different HTML and CSS. It means that the reference to that website will be different. So you could make a very specific website and have it immutable in that matter. Or you could use the IPNS for having the website always up to date with the latest changes. But Ryan will tell you all about that in detail for sure.
Yeah, I just got joined in. So if I recall the question, let's see, I had it up here. So how is it free? How does it work? Don't you need Filecoin for storing your data? So yeah, of course, IPFS is free, but you definitely rely on other nodes also having the data. Otherwise, if your node goes down, how other people get the data? So we have things like pinning services, of course, like Pinata, where you can pin the data, but then other people, like you might not want a centralized service doing that. So you can definitely use Filecoin, and it is free because if you use services like Web3.storage, they leverage free Filecoin transactions. The transactions are, Filecoin deals, the storage deals. The storage deals are free because they leverage Filecoin Plus. Filecoin Plus is think of it like a reputation system. Storage providers want to be storing as much data as possible to try to capitalize on that, and they want to get the reward for Filecoin that's effectively mined. So they have a lot of incentive to increase their reputation to try to make better storage deals by offering free storage deals to certain, users through the use of the Filecoin Plus reputation system. So Web3.storage has a certain amount of data cap, which has been allocated through the Filecoin Plus system, and they offer that out for free. So that's why, like, using Filecoin is free for smaller amounts of data, of course. And by smaller amounts, like, you can still store several gigabytes, and you can even request higher amounts. So if you were storing like publicly accessible data that benefits everybody, I'm sure you could ask to have that go up hundreds of gigs, or I've even heard of people asking for terabytes. So yeah, that's how it effectively achieves being free. And then for like really high kind of scaling kind of projects, it is very cheap to make a Filecoin storage deal anyways.
That's awesome. That's all the questions that we have today. But before we go, I would love to share my screen.
Okay.
I'm not
so,
able to.
Tay, I'm gonna drop you so we can share a screen. But thank you so much.
Thank you.
Go ahead, Trish. And I want to thank, while she's pulling that up, I want to thank everybody on the call today, our product teams, our partners here for this great presentation. And I wanted to thank all of you guys that are in the audience and that have joined this call. And we hope to see you on the next one as well, and in our Discord community. Okay, so go ahead, Trish, you're on.
Yeah, and thank you. I want to echo Shay, and thank you to our special guests, Ryan Discordian from IPFS and Tay from Gluwa. This has been a great session. So if you want to continue to connect with us, join us on Discord. There's a green button below that screen. So definitely continue the conversation there. And if you want to follow us on Twitter, we post blogs, we post information every week for a few times. And if you're really interested in Infura, sign up for a free trial, register on our website, or contact us for more information. But thank you so much for being here. Really excited, and definitely join us next month for another exciting lineup of sessions.
Yes, and one more thing before you go, about this session in particular, you can watch the replay. It'll be almost instantaneously after we end this call at the same exact link. All the questions that are in the queue, all the interactions on the chat will still remain, so that's really nice. And of course, like I said, if there's any questions that we didn't get, we'll try to address those questions in the Discord community. Trish will make sure we can kind of connect the dots for you guys for the Infura team. So thank you again, and we hope to see you next time. Thank you, everyone.
Bye, everyone.